Hi, in this video I am discussing a question on refraction of light in glass sphere. The question is shown on the screen. Okay, so when we consider angle of incidence and angle of refraction, for example, when we are using n equal, that is refractive index equal sine I over sine r, the angle, both the angles I and r must be measured with the normal to the boundary. Okay, so O is the center, the radius OP will be always perpendicular to the surface of the sphere. Okay, so we can measure the angle of incidence and angle of refraction. We should measure with the normal to the boundary or normal to the surface. So the extended line of the radius will give the normal. So the angle of incidence will be this one, where this red color line, that is the extended line of the radius, will be perpendicular to the surface of the, or the perpendicular to the surface of the sphere. Same way, the angle of refraction, finally, when the light emerge into air, that angle also will be measured with this extended line. This angle, the angle of refraction at the point Q when the light emerge into air, will be measured with the normal, which is the extended line of OQ. So at point P, we know the angle of incidence I. Angle of refraction will be measured with the normal, that will be R. You know the triangle OPQ is an isosceles triangle because this length OP and OQ are the radius. So the length of OP is equal to length of OQ. Therefore, this angle and this angle will be equal to each other, will have the same value. So this is R. Okay, now look at here. This is air. The sphere, the outside is air. We know that sine I over sine r equal n. N is the refractive index of the glass. So here this is air. So n is constant for given material. The absolute refractive index is constant. So n is constant. This is I. This is r. Sine I over sine r equal n. We know that this angle also r. I already explained because the triangle OPQ is an isosceles triangle. So this is R. So when we consider the refraction at Q, here also sine I, this angle over this angle should be the same n. Therefore, this angle also will be same as this angle. This also will be equal to I. Okay, so I showed these two angles are the same. These two angles are the same. Okay, so the question is we need to find the total deviation or total angle of deviation of the light ray when it passes through the glass sphere. So what is the deviation of light at P? Okay, so the light would have gone straight like this, but due to the glass, it has changed its path or it has refracted along this line. So this is the deviation, angle of deviation at P. So the total angle is I. You can see opposite angle. The whole thing is I, opposite angle. This is R. So the deviation at P, I can call theta 1. That will be equal to I minus R. That is in clockwise direction. That means the light has refracted in clockwise direction. It would have gone this way, but it has changed its path in clockwise direction. So I minus R in clockwise direction. Okay, what will be the deviation at Q? The light would have gone this way, but here also it has turned or it has refracted in clockwise direction. So this is the angle of deviation. This is the angle of deviation here. I can call it as theta 2. How much is it theta 2? This whole angle is I. This is R mean this is R. This angle is R. You can see that this is R, opposite angle. This is R. The whole angle is I. So theta 2 is here also I minus R. So deviation at Q, that is theta 2 is equal to I minus R. In the question they are saying the total angle of deviation is theta. So theta equal both in clockwise direction. Both deviations at P and Q are in the same direction, that is clockwise direction. So total deviation theta equal theta 1, that is at P, plus theta 2 at Q, both are in the same direction, that is I minus R plus I minus R, that is 2I minus 2R. Okay, so when we consider this triangle, the addition of the internal angle should be equal to 180, that is 2R plus alpha equal to 180. So R is equal to 180 minus alpha divided by 2, that is 90 minus alpha by 2, that is R. Okay, so that means 2R equal. From this I can say 2R equal 180 minus alpha. Substitute that here. So therefore theta is equal to 2I minus, theta is equal to 2I minus 180 minus alpha. So that is 2I minus 180 plus alpha. From that, make the I subject, that is I is equal to, or 2I is equal to, take to the left 180 plus theta minus alpha. So I is equal to 90 plus theta minus alpha by 2. Or I can say 90 minus alpha minus theta by 2. So I'll write it here. I is equal to 90 minus, take the minus outside, alpha minus theta by 2. Okay, so we don't need this. We can keep the I in terms of this format, right? Okay, so I got it in this format. I should get the R also in terms of theta and alpha. So how can I find the R in terms of theta and alpha? So use this equation, theta equal 2I minus 2R. Or you can say here R is equal to 90 minus alpha. R equal 90 minus alpha by 2. From this equation, R equal 90 minus alpha by 2. Okay, so I know that N equal sine I over sine R at this boundary or this boundary. I is the angle with normal to the boundary in air. R is the angle of refraction inside the glass sphere. So N equal sine I, that is sine, instead of I can substitute 90 plus alpha theta minus alpha by 2 over sine R. R equal, I already got it here from the triangle, R equal sine R equal 90 minus alpha by 2. Okay, we know that sine 90 plus theta minus alpha by 2 is cos theta minus alpha by 2. You know the general equation, sine 90 minus x equal to cos x. You know that. Same way, sine 90 plus x also cos x. So here sine 90 plus theta minus alpha by 2 is equal to cos theta minus alpha by 2 divided by sine 90 minus, that's the first quarter, that also cos, 90 minus also cos alpha by 2. That is equal to n. When you cross multiply, n cos alpha by 2 is equal to cos theta minus alpha by 2. So rearrange it according to the given the question format. That will give cos theta minus alpha by 2 equal to n cos alpha by 2. Okay.